All right, class. Class is officially begun. Are you guys ready? Yes or no? Are you? Are you ready? No? Okay, all right, that's fine. All right, well, you're going to be ready, right? So, on the board, there are a few options. Come on, come on. There are a few options for what you can do. So, on the left-hand side are a bunch of equations that will actually be for these parabolas that you see here. Okay? So I'm going to give you the first one. The first one is x squared. And then on the right board is a bunch of statements that you have to put on these lower boxes. So for this one, this is going to be the parent function. If you are watching the videos as I am advising you to watch, okay, you should know how to do this. If you do not watch the video that I posted up from last week, that isn't by me, but it was by like someone else, I would highly suggest you find someone that knows what's going on to help you out, okay? Because I'm going to give you about 5 or 10 minutes to figure this out, all right? You guys got to fill out these boxes with these different equations here, or these functions, and then these lower boxes for each space here with those statements on the right board. Okay. All right, guys, get going. Okay. So you guys could work. Actually, don't work by yourself. You absolutely need a partner. You need to work with at least one person. Okay. Please be nice and share the love. Okay. Talk to other people. Don't just give them the answers. Explain it too. Like what's going on. Where's Ivory? Where's Ivory? I'm not here. I don't know. You're in charge of where she is. I'm in sorry, it's just the way it is.
What would 3 be then?
Just because she's younger than me doesn't make me her guardian.
I didn't know she's younger than you. That's funny. Well, you're her guardian.
By like almost
A year?
a year.
Really? Oh, okay. Wow, I was just kidding. Yeah, no.
Mr. Would number 3 be x squared minus 2?
Where?
Number 3?
Yes, this is x squared minus 2. Yes.
Okay.
That is correct.
And then the other one is number 2 is x squared plus 2.
Where?
Number 2.
Correct. Yes, you're absolutely correct. Okay, we got someone that figured out 2 of the squares already. So.
Really?
Oh, did you?
I had no idea.
Did you know, Mr. Hibbert?
So white. I can't remember if this is so would it be negative squared or parentheses negative x?
What'd you put for the
Hey, don't get that.
translated plus 2 and then
I don't
translated
know.
Translated?
That's okay. No, I'm
Are you sure?
it's translated. I don't have
Yeah, you don't get one.
Wait, Dash, I'm sorry. You get one. Okay, so the thing is, this document had 2 pages to it. One was the key, one was the bridge. I print out both backs for everybody. Some of you guys got the one I want you guys to have, and some of you guys got the key, which I don't want you to have.
What did I say 4 was? Oh, I already got that done. I negative x.
This side is 5.
What was 5?
Fayad, come here. You need a paper. Okay. There you go. Fill that out right now, Fayad. That paper right now. Ask someone what's going on.
Okay, the bottom right corner is, I think, stretched by 2.
No, that would be number 8.
Okay, argue with each other. Okay. I like disagreeing. I like people disagreeing with each other.
How many times did I say one whole sentence when you say something to me?
Oh, right, there's a green mark. On 7.
How many times did I say
There's a green part right there. Those sentences.
Was it
Oh, it's
I
even.
think these
It's
are
the way
the
it's
parentheses.
all negative.
I think these are the parentheses. The ones with the parentheses. They are not. So.
Reflective.
Oh, yeah, it's the inverse. That's right. Okay. So it would be, this would be x minus.
Okay.
Anybody
9
need
is
help?
2x squared.
How are we?
And 8 is 1 half x squared, I think. 1 half x squared.
Very good. Very good.
Yeah. Oh.
Good.
Yeah.
So, because it's.
You get it's translated.
No, wait, y equals x minus 2.
It's opposite what you think. It's not x.
Translated by what? Like
Oh.
stretched by 1
I'll
half.
tell you this. It's in parentheses.
So it's
Stretched by 1
inverse,
half.
so probably
And then number 9 is stretched by 2.
It's not. It's not exactly what you think. It's opposite what you think. It's not x.
So it's x plus 2.
Yeah.
Oh. Well, what if it is? It'd be x minus 2.
Sorry, that's y is equal to x minus 2 squared. That's y is equal to x minus 2 squared. Dr. Hibbert. Who needs more time?
Mr. Wee, are numbers 1 and 7 the same?
Huh?
Are numbers 1 and 7 the same?
They look the same, but they are not. They are different functions.
What?
I want you guys to think about number 7 very carefully.
I figured it out.
Okay, you're fine. Big fan. I
Oh.
want you to think about number 7 very carefully.
Oh,
They
negative.
are. There is a different. Hey, man.
Negative x squared. Is that?
This one?
The one in. Ooh. The one in parentheses. That's what. Is that what it was?
Because think about it. Yeah, these two functions will give you. There are two different functions, but no matter what you plug in, you're still going to get the same answers for x.
Wait, so is number 7 still parent graph?
It's not. Number 7 is not parent graph.
It's not.
It is not. Tis not. Tis a not. Okay, I'm gonna freeze the screen. I'm gonna write in all the answers. Okay. Actually, I'm not gonna write
Oh,
it.
these are the reflected over the axis ones.
Good, man. Thank you. Unforgettable. Okay, I'm gonna give you till 9:31. So you have 30 more seconds.
What?
30 more seconds, and then you're turning this in. This is your pop quiz. I'm sorry.
Pop quiz. I know I can do like the names, I just can't remember all of them. I can do the quizzes, I think. Hopefully they're right. I haven't finished.
20 more seconds.
Like I barely
Better get it done, Fayed.
X
Better get it done. You got 15 seconds left. This is for credit, buddy. 10 seconds. Clock's ticking, Fayed. Clock's a ticking. 4, 3, 2, 1. Dr. Hibbert, can you please turn off the lights for me?
Oh, there's last names now? I actually know.
Dr. Hibbert, yes.
Right there.
Okay. Truth is, this is not a pop quiz. I was just kidding. Okay, I'm going to unfreeze the screen. And you guys can check your answers. I know it's kind of messy, but that says parent function. This says translated up to. This says translated down to over here. I want you to study over this. If you did not understand how to do this, I do have a video, okay? I do have a video. I did. Yeah, I texted you guys last week. I have a video up for translations. This is called translations, how you shift the graph over, okay? If any of you guys had trouble seeing how it shifted over, I always use a reference point. Like I always use the vertex, the highest or lowest point of the parabola, and I just write the coordinates if you really need to. This is like 0, 0, and then you get to see how it shifts. Now this is no longer 0, but this is 0, 2. The 2 is in the y position. So that means it went up in the y direction. And how you move equations up or down is you add plus or minus whatever number to the actual parent graph function, okay? But if you want to move it left or right, okay, what do you have to do differently from these two graphs than these two graphs here? Yes, Indigo. Yeah, so it'd be x minus or plus, but the only difference is, yeah, the whole thing would be squared in parentheses. I think what's easier to kind of think about is if it's in parentheses, right? If the whole thing's in parentheses, that should tell you right there, that's not going to move up or down, that's going to move left or right. And one more thing, you got to think opposite when it comes to horizontal. So if you're thinking it moved to the left, most people would be, oh, I moved to the left in the negative direction. I'm going to put the minus sign. That is incorrect. It's the inverse, okay? Up and down, yeah. I mean, that follows what you think in your head, okay? That took me a few years to get. If you're going up, okay, you add 2. If you're going down, you subtract 2. However, in parentheses, if you're going left, you got to add 2. If you're going right, you're going to subtract the number. Huh? Only in parentheses, yes. You guys ready for the... if you add a negative sign in the front, what happens to your parabola? Yeah, it reflects. It kind of shoots downwards, or it reflects technically over to the x-axis, okay? This one is crazy, but maybe you guys couldn't tell, but number 7 is not the parent graph. It's technically reflected over the y-axis because your equation is it's now negative x in parentheses squared. Can anybody describe why this should give me a very similar graph to the parent graph? Okay, yes. Okay, so can someone just give me x value really quick on the top of the head? 3, okay? So if you put in 3 squared here, right? X is 3. That would give me the y value of what, Hassan? What is 3 squared? Okay, right? It gave me the y value of 9, right? But, I gave you number 7, and I give you this. Is it going to change? If I plug in 3 into minus x squared minus x, it's now going to be negative 3 squared. What's going to happen now, though? What's my outcome going to be? Hassan again. And it's still 9, okay? The only difference is the coordinate is, yeah, I guess now what was once... No, actually, yeah. I don't even see how it's a reflection. It should just be the exact same thing, but I think they call it a reflection over the y-axis. Okay, I'm not gonna really grill you on the reflection here, unless it's blatantly like this over the x-axis. But over the y-axis, I'm not gonna dock you any points if you don't get the reflection over the y-axis. Okay. Anybody have a problem understanding this though? Why is it that this is more narrow than it is wide? If I have a bigger coefficient number in the front. Coefficient is the number in the front, so it's 2x squared, okay? Why did it make it skinnier? That's hard. That's really hard. Yeah, fire. Yeah, if you think about it, again, Hassan, I'm picking on you again, buddy. I'm sorry, you're just a fun one to pick on today, okay? If you put in the x value of 3, right, into the parent function, okay? What would my y value be after I plugged it into the y is equal to x squared? 9, right? Gotcha, okay. However, over here, what's that y value going to be in 2x squared if I plugged in 3? Yeah, so if you think about it, what was once maybe over here is now, or I'm sorry, what was once maybe over here, okay? Like, let's just say 3 comma 9 was over here, is now no longer 3 comma 9, but it's like even higher. So all the points shot up into a more vertical direction. Does that make sense? This is 2, 3, I think. This is a little bit of review for 2, 3, or 2, 4, I think. Okay, everybody got this so far? Okay, if you don't know, keep this now. This is going to be of a very very good help to you guys. Okay, all right. Let's go ahead and begin notes. So let's grab a white piece of paper. Okay. All right, I want you to solve this. This is going to be really easy, okay? So before we do anything, don't write anything down. Just look at this and just solve this in your head. I know you guys can. Yeah, just solve this really quick. 4x squared minus 24x plus 35 is equal to 0. I want you guys to solve that really quick in about 2 minutes, okay? Go, okay? Go ahead and solve this out. I want you to solve for x really quick. Yeah, just right now. Go. Okay? Don't write it down, okay? Or if you need to write it down, you can. Just on a scratch piece of paper. I know this is like easy stuff for you guys, so just like figure this out really quick, okay? You guys got about a minute and a half now, all right? So figure this out. Solve for x. Okay, I don't see a lot of papers. I don't see a lot of pencils moving. What's going on, guys? Okay, all right. Oh, what's x? What's x? What's x? What's x? This should be just butter, just hot knife through butter. So simple, so clean, so nice, right, guys? Yeah? No? Yes? Yes? No? No? Yes? I might be trying to prove a point here. I don't know. Okay, you guys got about a minute, 15 seconds. No pressure. I'm just, giving you a time. That's all. Just finish now. Hurry up. But, just take your time at the same time. I love the waiting because you're not going to get to wait. You got to go. You got to hurry. You got to hurry. But no, just take your time. Just no pressure. Okay, 1 minute, right? Cool. Is it prime? I don't know. Just figure it out. It's easy. Okay. Okay, Dr. Hibbert. Sorry, I just love saying your name, but that ends up making you having to do more chores. So can you close the door for me, Dr. Hibbert? Okay. You also only got like 30 seconds left, so the faster you close the door, the faster you can get this problem done. Dr. Hibbert, can you close the door, please? Stop it. Wait, did you just tell me to stop it? I'm your teacher. Come on. Okay, 20 seconds, guys. Okay, we don't got a lot of time, but, just chill out. Don't worry. Don't freak out about this stuff. Okay, I'm just going to speed this up. 10 more seconds, guys. Okay. Okay, all right, we'll just stop, okay? What is x? That was easy, right? Okay, well, for one person. Was that easy? Was it easy to recall what the heck we were supposed to do to solve for x? Okay, that's mixed answers. The whole point was it's not. I don't think it was. Everything we've learned up to this point to solve for this stuff, the diamond stuff and all this other junk, okay, is not easy, all right? I finally want to get to this section because I know if I gave you this on day one, you would have hated it. But hopefully now if I give it to you, you might have a deeper appreciation for it because you don't have to memorize a whole bunch of stuff. You guys ready? Okay. What do you guys think I'm talking about? Yes. Again, it's going to look complicated, but trust me, this is the only thing you need to know from now on to solve these type of problems, okay? All right, Dr. Hibbert, can you please now shut the door, okay? Okay, so go ahead and write down this as notes. You don't have to write down this guy. What's funny is you'll end up writing him down anyway, but don't write him down right now, okay? Solving quadratic equations. Quadratic equations are anything with x squared, okay? So when I say quadratic equations, it just is a fancy way of saying, oh, it's an equation with x squared, right, Mr. Yes. Yep. So by using the quadratic formula. Does anybody recall what the quadratic formula is or what it may look like? Okay, I just wanted hands to see if anybody was exposed to it before, okay? So this is the note, so we're taking, this is 2-5. And pretty much, if you had to summarize this whole section should just be called the quadratic formula, all right? Okay, so here's what you're going to do. If you can't find, or you can't factor out a polynomial, you have a choice here to write on your paper. You can put comprehensive, the most comprehensive, or if I was you guys, I would be like the most, oh crud, I forgot what I was going to say. I would just say the best, the most best way, okay? The most best way, okay? I think comprehensive is a little bit more accurate here, but we'll just say best. Most best way to solve for x-intercepts or roots. So whenever you see anything, when they say, like going back up here, if they say solve this equation and they set it equal to 0, they're asking for the roots or x-intercepts. And what you're required to do typically is you have to do this. Remember, you guys had to like factor that out into like 2 binomials and figure out all the other stuff. You no longer have to do that. Okay. You remember that's like, I remember Katrina, you'd come in for like tutoring and ask me questions, and you'd have like 18 steps, and you'd be like, I'm not going to memorize all this stuff. Okay. I don't want you to do that anymore. Right. I want you to toss that out and just learn this way. This is probably the easiest way for you guys to understand this stuff or to solve these questions. So for a, let's see, solve for a quadratic equation. After you finish writing this down, try reading this to yourself to make sense of what you just wrote. I was definitely the type of student to just be like, all right, the teacher wants me to write notes, I'll write notes, but I'm not actually paying attention to what I'm writing, okay? Take the time to actually read what you're writing, right? So if you can't factor out a polynomial, like you can't, right? Like you're freaking out, like I can't do this, okay? The most comprehensive, best way to solve for these x-intercepts or roots for a quadratic, EQ, that's a Q, okay? Don't judge, okay? That's EQ dot is the quadratic formula. This is like the best. You never have to go back to any other way again, okay? Would you guys like to see an example of how this might work? Oh, actually, let me give you the quadratic formula. It's so easy, it just rolls off the tongue, okay? Yes, it does, Indigo. Yes, it does. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Whoop. Sorry, I got ahead of myself. That was smooth as ice. Negative b squared plus or minus the square root of, the square root of b squared minus 4ac over 2a. Okay, I know I told you that this would be the best way, and you're probably thinking this is not the best way at all, Mr. Wee. I want to punch walls, and I want to punch holes into walls, but trust me, if you know this, you never have to do anything else again. Yes? Huh? Okay, I didn't ask for the answer down, did I? Well, actually, I did. I did, because I did ask you to solve for this, so thank you. But hold on. Hold on to your answers. Well, what'd you get? Well, let's see if you're right or wrong, okay? Okay, no pressure now, because we're just all going to be eyes on you. Did Hafayad get it right or wrong? Okay, so let's go back to the example problem. So hold on. Shh, wait a minute, guys, okay? So the quadratic formula, remember, I'm solving for x values. I'm solving for x-intercepts. I'm solving for roots. I'm solving for what x is equal to, ... I don't know what x is equal to. If you remember the old way, you would have to factor it out in 2 binomials. You'd have like 2x plus something and 2x minus something or something, and then you'd have to set the equal to 0. Then you'd have to do the diamond problem. You had to do all that stuff just to find out what x was. You no longer have to do that, okay? So on this first exam, I will give you the quadratic formula. I would just write it out, but it's up to you for you to know how to use it, okay? Do you know how to use this and what it's used for? So what this is let's go back. 4x squared minus 24x plus 35 is equal to 0. And you must solve for x. Does anybody have any suggestions for what we should do now to solve for x? Okay, Indigo. What are you doing? Like if someone's, what is she doing? Okay, because half the people here are like, what is she doing? I don't know what she's doing. Okay, so the first thing that you might want to do is identify what A is, B is, and C is. A is 4, B is equal to negative 24, and your C is equal to what? Okay, why would this help us to identify where your A, B, and C is? What do you guys think so far? Not you two, okay? Does anybody else have any suggestions for why this would help us to know? Marla? Yeah, you're going to need them to plug in the formula, and then once we plug them in the formula, what should we end up getting once we plug the answer? Is that it? Do I need to do anything else? That's it. Okay, that's why I know it looks really scary. Okay, this is probably the scariest equation you've ever seen in your life up to this point. But it's not that bad. So negative b, so you're going to take the negative of b, which is negative 24, plus or minus the square root of b squared, which is negative 24 squared. Okay, so there's going to be some high-level math here. Or not high-level math, but like bigger numbers, basically. times 4AC, so it'd be 4 times 35, all over 2 times 4. And then this should give me 24. Did anybody simplify what goes inside here? What's 24 squared? Yeah, fired. Yeah, okay. That's 24 squared, and then what's 4 times 4 times 35? Okay. And what's 2 times 4? Huh? Oh, what? 40 what? Oh, Ruby. Okay, you scared me. Well, that's okay. Nice check. Okay. So 24 plus or minus the square root of, I think 16 is left over 8. So x is going to be equal to 24 plus or minus 4 over 8. That means you have 2 potential answers. I think one is 28 over 8. If you add 24 plus 4, and the other one is 24 minus 4, which is 20 divided by 8. Okay, if you divide both the top and the bottom by the greatest common factor, which I think is 4, like 4 and 4, then that should be 7 over 2. And then this one is, I think the greatest common factor is still 4. So that's 20 divided by 4 and 8 divided by 4. I have 5 over 2. So supposedly, those are my answers. Let's double check to see if this is correct. What this means is if you did it right, these should be the x-intercepts for the parabola, okay? What did you say? Oh, you wanted the calculator? All right, get the calculator. I like that. You just get it. Oh wait, I pushed the wrong one. Okay, you guys don't want to use fancy Desmos? Oh, I'm getting dissenting opinions here. I got calculators better. Yeah, Active Inspire is a misfudging of the fingers here. If I missed the we, okay, sorry. Okay, so here's what I'm gonna do. I'm gonna plot. What's the equation? 4x squared. Yeah, 4x squared, right? Guys. Okay, now what? What's the rest? Okay, minus 24x plus what? Okay, we're gonna graph that. I'm gonna do a new zoom. Okay, so I just went to zoom, and I went to zoom, and I pressed 6 to go to the standard zoom. Okay, that's factory setting zoom, right? It's funny, it's how the factory set it in the beginning, and yet it can't comprehend what it was set to in the beginning. That's weird. Okay. Oh, Fayed, master of the... All right, master. Okay, so here, I'm going to trace it. You want me to zoom in a little bit? I can zoom in. Okay, so if you look here, that is approximately 2.34, okay, for that x-intercept. Can everybody see that? How it's kind of like near the x-intercept? Can someone check for me, what is 5 divided by 2 on someone else's calculator? What's 5 divided by 2? So is that about 2.5? I know it's not perfect, but is that about 2.5? Oh yeah, right there. Yeah? You guys see that? Okay, that's about good. And the other one should be equivalent to 7 over 2. So we're looking at about 3.4. What's 7 divided by 2? 3.5. Okay. 3.5, no pressure. Okay, 3.5. So you just solve for the roots of this parabola. Okay? You guys got it? You guys want to try one now? Okay. Come on, Jacob. Come on, Jacob. You got this, buddy. Okay. Okay, so stretch out for a second. I'm going to grab you a problem from the book. What'd you say? Oh, right here, right here. Follow my arrow right here. Okay. This is 2-5. Unforgettable. Okay, Here you go. Here you go, kids. Here you go, children. Okay. Okay, I'm gonna freeze the screen. There you go. Can you guys see that? No? Can you see it now? Can you see it now? Okay, there you go. Okay, all right. Solve this. Solve for the x values of 3x squared plus 5x minus 12. Okay? Go. Everybody up on the board now. Everybody up on the board. Up on the board. Up on the board. Up on the board. Andale, 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 andale. Slow down. Don't run each other over, okay? I didn't tell you to rush. Yeah, go ahead. Yeah. Yeah. Uh-huh. Proposal? Sorry about that. It's because I know your proposal is now was an honor. What'd you say?
Oh, do you remember that?
Hey guys, markers are in this bucket over here. Okay?
Do you want to do the reading?
Markers are in this bucket behind Katrina.
I can just tell you the equation.
Fayad,
Plus or minus
indigo. You work with indigo. Go to indigo.
b squared minus
Hey,
4ac.
come on, Fayad.
Square the whole thing squared. Square root, that's right. And then over 2x. 3x squared plus 5x minus 12 equals 0. So,
Okay, please, guys. Letters.
So negative 5.
No, not C squared. B squared.
Let me get calculus. That's 24, by the way.
No. B squared
Yeah.
Oh
Don't quote me on that. I just quoted you on it. No. Okay, so minus 5. It's got minus 5 there. Plus minus 5 squared 24. Then minus 4 is minus 4. This one's a. So what?
It's 4 times.
Oh, it's one everywhere. Last night.
4AC.
Yeah, 4AC is it's plus 1.
So okay,
Yeah,
so
because
4.
you see always a minus, and then it's minus 4AC, minus 1.
So 4AC is 4 times A, which is 3. So 4 times 3 times C, which is negative 12.
So minus 1 is plus 1.
Yeah.
You told me it was 2.
Because it looks like 2. Because we
told me it was 2.
look. Because when you guys said you guys were defining C, we accidentally cut off the.
Brandon, you told me it was 2.
Don't worry about it. The methodology is correct. That's all that matters. It's just minor and
Okay, so 12 times.
no one's fault.
I told you it was 2.
No one's fault. Where's my book? Oh, it's right here. Wait, is that oh, this is my Yes. So like both the plus scenario and the minus scenario, you still have to divide it by. So show me.
That's why I said don't do that.
Yeah.
Okay, does this look like...
All right, guys, let's have a seat. I'm gonna turn the AC a little bit. I think it's getting kind of hot.
No, wait, no, one over here.
All right, guys, have a seat. Okay. It looks like you guys are on the right track.
Because we went behind.
That's okay. No, yeah, because it's just like a minor stumbling block. But you guys All right. Shh. Please check your answers. Your solution should have been -3, 4/3. Okay. That was a resounding yes from Sophia. Very nice. Okay. Okay. Shh. Okay, so let's go back on your notes really quick. Okay. Everybody, please look at your notes. Okay, so there is a weird term that you need to learn, okay? It is going back to the original quadratic formula. In fact, out of all your notes, this is probably the key centerpiece for your notes. So go back where you wrote the quadratic formula and maybe circle it or put a square or a border around it. That's a Q. Sorry. Yeah, I know. What are you talking about? Huh? All right, hold on, guys. Shh. I can't. Guys, I can't hear Fayad. Ruby, guys, hold on. Wait, I'm sorry. What'd you say? Well, we don't. We don't. Okay, so there is a part on the quadratic formula you need to know about. Okay, it's not necessarily the top half, but it's this weird portion that goes underneath the square root. Underneath the square root, the b squared minus 4ac, I want you to circle that portion really quick, maybe preferably with a different colored pen, but if you don't have one, it's okay. Just draw an arrow to the side. We call that the discriminant. Okay, it looks really weird the way I spell that, but look, the discriminant. That's D-I-S-C-R-I-M-A-N-T. You don't like the way I wrote it? It's okay, because down here, we're going to write it one more time. That's called the discriminant. And then down here, I'm going to write right here. This is the, hopefully I get another chance at glory here. The discriminant. Okay, hopefully that's a little bit more clear. And then there are a few things you need to know about the discriminant. Okay? If your number, so it's basically the number underneath the square root sign. If you have a positive number like we did, we had positive 16, right? You will get 2 roots. If your discriminant is 0, you will only get 1 root. Okay, why do I say that? Why do I say if your discriminant ends up being 0, you only get 1 root? Whereas if you have a positive number here, you get 2 roots. Why do you think that is? Look at the equation briefly. It's negative b plus or minus the square root of whatever the discriminant is over 2a. Dash, what do you think?
0 is like not positive or negative. Like it's the same no matter what.
Yeah.
Subtract it.
So if you take your b squared and you subtract 4ac from it and you get 0, right? What is the square root of 0? 0. So if you're adding negative b plus or minus 0, are you getting two solutions anymore? No, you're getting only one. You're adding it to 0. You're subtracting it from 0. Guess what? It doesn't matter. It's the same thing. Okay? So you only get one root. Some people might even ask, what happens if you get a negative number for your discriminant? What do you think I get for the roots there? Well, then you two. Hold on. I want to take a break from you two. You guys answer everything. Okay, what do you think, Luciana? You don't get a root. Well, you get no real roots. Because it's not real, is it? Get it? It's an imaginary one, so it's not even real. So, in case you're not understanding what they're saying, you're going to learn that the square root of a negative number is imaginary. And it's going to be funny when I finally teach you what imaginary looks like. It's just the letter I. So, yeah, the square root of a negative number is imaginary. So, it's not real. Get it? It's not real, right? So, if you have a discriminant of don't do this. Don't write this, okay? If you have a discriminant of a positive number, you should get two roots. You have a parabola with that hits the x-axis twice. What about if you had a discriminant that only had, or the discriminant of 0, and you only have one root? What is that going to look like? What is the parabola going to look like here? Anybody want to give it a shot here? What do you think the parabola is going to look like? Fayad, okay. Does that make sense? Anywhere. That works and that works. You only have one root, okay? You only have one root. That means it touches the x-axis maybe only one point, the vertex, okay? What about the situation where you have a discriminant of negative and you have no real roots? What the heck do you think that's going to look like? Is that going to be complicated? Okay, Fayad, what do you think?
It's where the points are not touching the x or the y.
Have you guys seen that before? A parabola just kind of stays out in the, like right here, just stays out there and doesn't really touch the x-axis. That totally happens. Okay, so that's if you have that happening and you plug in your equation, like your y is equal to x squared, blah 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 blah. If you plug that into the quadratic equation, you'll find out that your discriminant will come out negative. Okay, does that make sense so far? I am going to ask you a question about the discriminant, okay? So on your exam, you are going to solve a problem, and then at the very end, I'm going to say, okay, how many roots does your answer have? And then all you need to tell me, and I'm going to ask you about the discriminant. Was your discriminant positive or negative? And then I ask you, how many roots is it going to have? And then you just tell me, it's going to have two roots, it's going to have one root, it's going to have no real roots. Any questions? Any questions? Okay. We're going to move on. Okay, you guys did wonderful. Well, will you guys do wonderful anymore? I don't know. Okay, copy down these notes. 2-6, you can start on a new page. This is going to be a new section. 2-6, analyzing functions with successive differences. Okay, we might be able to, yeah. If not, 2-7 is going to be a video. You like videos, don't you? You're not the only one. I'm sorry. Yeah, but I have to make sure you guys get practice too. So, or else. What? I'll show you exactly what I want from 2-7. It's just gonna be graphing. That's it. Oh, I see. Yeah, it is weird. Yeah. Huh? Okay, go ahead. Yeah. Go ahead and take a minute to write this down. You can chit chat with your neighbors a little bit. Okay, I'll give you guys like 5 minutes to write this down. These are 3 types of lines. One of them is called a line. The other one is called a parabola. Huh?
One of them
Yeah, one of them is literally called a line. It's ridiculous. Yes. It's just a standard linear function. If you want to know the technical name for it, an exponential is where it just goes up. If you were making money, which of these lines would you want?
The exponential function.
When it goes up exponentially. I mean, the linear is not too bad either, right? But in this case, the linear is going down, so you probably don't want that trend for your
If it was going up, that'd be fine.
Yeah. And then if you think about the parabola, it's like, oh, we were once rich, and then we lost a little bit of money, and we're right back where we were. Okay, that's good. That's good too. But you want to start from the bottom, and then you want to get to the top.
And work your way up.
Work your way up.
How much though?
Come on, shh, Jacob, give me 1 second. Maro, what'd you say?
Oh, never mind. I thought that was a point, but it's a 0.
Okay, now continue. You can go ahead and talk. Okay, all right. All right, Maro. Sorry about that. Yeah, if there's any confusion. So what I wrote here are the equations, the general equations for these curves. To be more comprehensive here, instead of just calling them lines, they're different curves. Okay, this is y is equal to mx plus b. I think we've heard of that before. We just learned about this the past few weeks. Y is equal to ax squared plus bx plus c. And then the new one that we're not going to touch on a lot except for this section is y is equal to ab to the x power. Okay, b stands for base. And then the curve that you see is when your b is greater than 0. I'll be honest with you. That's a case where your b is a number that's greater than 0. Okay? Because your curve might look a little different. It might do different things if your b is actually not a positive number. Do we need more time? All right. My plan is I'm going to give you 3 tables of values, XY tables, and just from those things alone, you should be able to determine if you're dealing with a linear, quadratic, or exponential function. You guys should be shaking in your boots. I'm sorry. Terrified. That's an old expression, okay? Quaking in your boots. Why? Oh. What? Well, you shouldn't be that scared. But you should be mildly scared, not quaking in your boots. You can't quake in your boots. Okay. Give yourself some room. Okay? Shaking in your shoes. I think boots illustrates it very well. Okay? Because if you can make boots shake, you're freaking out, right? Is anybody wearing boots here? Brendan's wearing boots. He's not, but I made you look, didn't I? Ha! That's what you get for making me feel awful inside, Ruby. They say boots? Oh, yeah? Really? Okay. Very nice. Okay. You know how they say it in Vietnam? Yai. That just means shoots. Yeah, shoes. Okay. So here's what you're going to do. You're going to write, okay, give yourself a little bit of space, okay, for each one. I'm going to say about like at least 5 or 6 lines for each one. Maybe even 7, okay? Shh. Okay, so go ahead and write this down. You're going to write these table of values down. And I don't want the people that have already done this section to say anything, okay? Keep it to yourselves. But would you be able to tell, for everyone else, would you be able to tell if this was a linear, exponential, or quadratic function just by looking at the table? Okay, one. Did you do the section already? Then don't say anything yet, Indigo and Fayad. Okay, I can see you guys are very... Sorry. Someone's quaking in their boots, right? Oh, we can't see it! We can't see it, Mr. Wee. You're shaking in your shoes. Okay, so it's milder. It's a little bit more mild. Okay. This is xy. This is going to be -3, -3, -2, -7, -1, -9. And this is going to be 0, comma, -9, and 1, comma, -7. Any guesses as to which one is which? Which one is quadratic? Which one is exponential? And which one is no? Petunia, was that a hand up for a second? No? Okay, okay. All right.
Just with looking at it?
Just by looking at it, could you tell? Oh, yeah? No. Okay, I'm going to do one more table at the bottom here. Okay. I gave myself a little bit of space for writing for each one. This is going to be -1, 1, 0, 3, 1, 9, 227, and 381. Yeah, dash. Wait, did you do the section already? The homework? Oh, you didn't. Okay, so what do you? Oh, okay. Dash, go ahead. What do you? Shh. How do you know if it's linear? What goes up by 5? Okay, so if you take like the difference between these two, you had to add 5 each time, right? Add 5 each time. Add 5 each time. Actually, that is the... Dang it. Dash. Dash! Okay, yeah, it's my fault. It's not Dash's fault. Sorry. But the blame's got to go somewhere away from me, Dash. I'm sorry. You got to take the blame here. So, Dash. Okay. I'm just kidding. Someone had a hand up. Yes. Sophie. Okay, hold on. You're not letting Mr. Wee finish. I'm not as quick as you. I'm not as quick as you kids. Okay. Okay, hold on. Before we start anything, let me name this whole section. This is called choosing a model. Choosing a model, meaning quadratic, exponential, or linear. Choosing a model using differences or ratios. Okay? So the first one you found was a linear function. This is absolutely correct. This is a linear function if it passes the first differences test. The first differences test is all you need to do is you need to see if the y values are going up by the same value. Are they indeed going up by the same value? Yeah, Dash identified that as being true. If it passes the first differences test, you have a linear function. Okie dokie. Now, Sophia, what do you think the second equation or the second set of data is? Sorry, I thought you had to write more. Who knows? It was just for safety reasons. Or, I mean, precautionary reasons, sorry. Precaution and safety go hand in hand for me, so I always mix them up. Okay, Sophia, did you want to add something to this? Oh, okay, so that's how you identified it for parabolas, right? So if you guys notice, it's kind of like a mirror, -3 to -7 to -9, and then it goes back to -9, and it goes back to -7 again, right? So that's pretty convenient. A parabola kind of does it. It kind of goes up, it kind of goes down from one way, stops, and kind of goes back up. So the y values end up mirroring each other. But you can't always tell. What if they give you a data table that only gave you these values? It's really hard to tell just given those values if you're getting a mirror image. Yeah. What do you think, Luciana? Okay, that's another way. Okay, but do you want me to show you the formal way, I guess, the surefire way, so you can never... So let's try the first differences test. If it passes the first differences test, then we have a linear function. Are these the same differences? Okay, -3 to 7. Okay, what did we have to do going from -3 to -7? We had to add 4. How about from -7 to -9? You had to add, or you had to... I'm sorry. So the first one is subtract 4, subtract 2, and then this one is 0, right? And then this is, you had to add 2, okay? what if, so these are not the same values, right? So this is what we call, yeah, so we're going to take the second difference and let's see if these have the same differences. So from -4 to -2, what do we have to do? We had to add 2, right? How about here? And how about here? Okay, folks, this is what we call the second difference test. If you pass the second difference test, you are now a quadratic function. Try this test on the last guy here. I think you might already know where I'm going with this. I'm going to freeze this really quick, and then you guys do it at your own desk. You can check with your partner really quick. Okay, did anybody see if it was a quadratic or linear function? Oh, I want to give it to someone else, Fayad. Thank you, though, Fayad, for always volunteering. I appreciate that. Anybody see if it was a linear or quadratic at all? Anybody test it out to see if it was linear or quadratic? No? Yes? Yes? No? No? Yes? No? Not you? No? Do we have a conclusion here? Yeah, Sophia? Wait. Shh. What'd you say, Sophia? Okay, so hold on. So let me unfreeze this really quick. I tried my best. Okay? I tried my best. The first and the second difference test. It does not pass the first or second, or the first or second difference test. But what did you just say, Sophia, about each of these numbers here? Like, what did you say? Okay, so let's rewrite the numbers here on the bottom on the y part. 1, 3. Actually, I don't think I'll have room on the front, so I will have to continue on the back. So excusez-moi. I'm sorry about this. Let's see if I have a good memory here. It's 1, 3. So these are all the y values. This is 9, right? Marwa, how are you knowing this stuff? Okay. Okay, I think some of you guys might have already seen this and might already have caught on, okay? But you're not subtracting, you're not adding anything, but these numbers definitely have something weird going on. They look like multiples of something. So, what? Sorry? I thought I did my math correctly, but not always, right? What you do is if you're not sure what to do, this is 81, sorry about that. You take the second number and you divide it by the first. That's 3 divided by 1. That's 3. This is 9 divided by 3. That's 3. This is 27 divided by 9 is 3. And then 81 divided by 27. What this tells me is that each number, each time, was being multiplied by 3. This is not called a differences test. This is what's called a ratio test. This is the last test you need to apply to see if your function is either linear, quadratic, or exponential. Ratio test passes. That means therefore. So I'm going to write this weird thing, 3 dots. That means therefore. Therefore, this equation is exponential. It's an exponential. What's up? Yep. 3 dots means therefore. You're going to see that a lot once we get to this thing called proofs. You have no idea what I'm saying, do you? All right. Prepare yourself, young child, okay? Have fun while it lasts. No, I'm just kidding. Proofs are actually really fun, but they can be really tedious and tough, okay? So the equation is exponential. What if we don't pass any of the tests? It's not a prime. It's just... It's what? It's undefined. No, it can be defined. It's just simply not linear, quadratic, or exponential. Sorry, yeah, it's nothing fancy. It's just literally not those three things. It could be something else. No, it's not, because there's other types of curves out there that have names to it. So we're just gonna say they're simply not linear, quadratic, or exponential. Which ones? I just call it an S. Yeah. There is a more formal name for that, but I can't tell you on the top of my head what that is right now. Sorry. Yeah. I like your inquisitive eyes. Okay. All right. I'll think about what you just said. Okay. All right. Do me a favor. All right. All right, kiddos. You're gonna have to go on the board. All right. You kids are gonna have to go on the board. Oh, I haven't even told you about what to do yet, but you already... Dear God, just calm down, kids. Jeez. Okay, test these two equations. Jeez, guys. Calm yourselves. This is your board. All right. Ah! How could you? It's okay. It's all right. It's no one's fault but Katrina, so it's okay. No, I'm just kidding. I'm just kidding. Oh, I'm sorry. Yeah, sorry, Katrina. It's no fault but your own. So yeah. Nope, there's two. Shh! Don't get into the microphone, young lady. You're doing all of them. You silly goose. Yeah, I'm sorry, Brennan. Yes, you're doing all of them. I'm gonna throw you a curveball, guys. Oh, that's too complex for me, what you just said. Okay, I don't know what you just... Is it frozen? Does it say freeze? Okay, we're good. Jacob, you can be inspired, but don't just blame it.
Yeah. We will defend this with our lives. And my life. We will defend this with our lives. Well, I assume that's short. Or that's a song. Okay, you
Wait, you had a really good suggestion. What was it? It was about making.
No, it wouldn't be.
Hey, have a seat when you're done. Bless you. You get snot all over my board. This is called cleaning agent, Mr. Lee. Alright, put it against the wall, please. And please watch out. Don't hurt the song. Don't hurt him.
I'm going up. I use Swifty Slide.
I don't know how long it's been there. That's my rule. And I eat it. No, you did. You did. You did.
Oh my god!
You did. I'm watching you. All right, young ladies, you have to have a seat. I'm sorry. Yes. You are persistent. You did not let go. Okay, go ahead and have a seat. That was very good. All right, guys, have a seat. Yeah. Hey, sorry guys, there is a sign out sheet or sign in sheet. Make sure before you leave that you guys sign in. Okay, so don't confuse my brain right now. Okay, it's on its last limbs right now. Okay, shh. Okay. Secret, these actually lead directly right into your next set of notes, which we only have 5 minutes to do. So that means I'm not going to get through everything I want to. That means I get to make videos for you guys, and you guys get to watch it. Yeah, okay, one person. Thank you, Ava, so much. Okay. Sorry, that sounds really violent. Thank you, Ava. Okay, I have to, because it's getting recorded too. Okay, thank you, Ava. I sincerely do appreciate it. Ava. Okay. All right. So writing an equation. Okay, writing an equation. Shh. I did see, Petunia, your work. You did actually go. I wanted to give you another bonus question, but I didn't have time. Shh. So let's rewrite the first example I gave you, or not the very first, but the first one that I wanted you to do on the board. -2, 11, -1, 7. These are going in your notes. 0, 3, 1, -1. Sorry. Writing an equation, write this down in your notes. This looks exactly like the example I just gave you. And then I'm going to apply the first differences test. Did it pass the first differences test, guys? Yes, I subtracted 4 each time. So that checks out. This is a linear function, right? This is a linear function. Shh. But the name of the game is to write an equation. Can you write an equation with the given information that you have right now? Can you? Wait, you can. How? Okay. So hold on. What is the equation? Go back. Hold on. Give me 2 seconds. Okay. Go back to your original notes. What is the equation for a line? Okay. Yes, Katrina. Okay. Y equals mx plus b. Shh. Huh? Okay, so -4. Hold on. Guys, hold on. So let's figure out each component. Shh. with your data table here, I know it's very tempting to just put the differences as your slope, but be very careful. So one suggestion I would make is, as long as you know that each increment is going up the same, okay? Some tables don't do that. It goes from -2, -1 to 0 to 5 to 8. You got to make sure that your table goes up equally. What you do is you go up by, let's see. Yeah, you check the differences on the top, okay? That should just that should be +1 each time. Shh. That should be +1 each time. Or depending on what your table says. I know it's hard to see. What I would do is I would take the bottom difference, which is -4, and divide it by the top difference, which is +1. That should give me -4. So my slope is -4. The tricky part is the b. Where can I locate the b on my data table? Yes, Ruby. Yeah, because it's the y-intercept, which is, yeah, b. So your b is going to be equal to 3. So your final equation is y is equal to -4x plus 3. That was brilliant. Okay. I do apologize. This means the next 2 problems will be on a part 2 video. And then there's going to be a separate video for 2-7. Otherwise, please pack up your stuff. Make sure you sign in and stack your chairs away, kids. All right? And you guys have a wonderful day. Okay? You guys have a good day, guys. Okay? Have a great day.